In general, when we're looking to see if a sequence converges or diverges, that's when we're taking a limit. So be careful that you're writing the fact, I'm going to take a limit. And you're always taking the limit as n goes to infinity because you're trying to see if the numbers go somewhere. So I'm going to take the time to break this up to 5 to the n times 5 to the 1. And then this is 3 to the 3n is the same as saying 27 to the n. All right, so let's look at what we've got. So if I was to look, I would have the number 5 times 5 over 27 to the n power. Okay, let's think about this. This is what I'm going to refer to as the K-limit theorem. And I'll let you look it up in your notes. If that number K, absolute value of it, is smaller than 1, then the whole thing goes to 0. And so then you can say it converges. And you do not need to say the word K-limit. I just want you to know that's what it is. Let's look at this one. So we're going to take the limit as n goes to infinity. And I'm going to break this up. So 2 to the 2n times 2 to the negative 1. And then this is 3 to the n times 3. Because you know if there's addition or subtraction up in the exponent, it's multiplication downstairs. So let's see. This 2 to the negative 1, I can pull that outside and make it 1/2. And then this 3, I can pull that outside as 3, right? So then what am I left with inside? As n goes to infinity. I'm interested in the number to the nth power. So let's think about this. Isn't this 4 to the n? And this is 3 to the n. And I don't need to write another step. Do you see that the number to the nth power is 4/3? That means it's infinity. And as a result, that sequence diverges. If I was to take a limit of this one, I would get, you know that sine gives you, what, second d and e over an infinity. What? Okay, so that's where you say, oh no, I need to use squeeze theorem. Okay, so what are the steps for squeeze theorem? So you start off with sine squared in the middle, and you need to know that sine squared is between 1 and 0, right? Not negative 1, 1 and 0. Then I'm going to divide everywhere through by 3 to the n. So 0 sine squared of n over 3 to the n, 1 over 3 to the n. And remember squeeze theorem, you take the limit of both of these as n goes to infinity. Well, that's 0. I don't need to say do anything with that side. This side here, limit as n goes to infinity, 1 over 3 to the n. 1 over infinity is 0. Since I have a limit of 0 and a limit of 0, therefore, I can say that this sine squared over n over 3 to the n converges to 0, and you need to say by squeeze theorem. So it's not every time that you see sine or cosine, because, what happens over here? What if I take the limit as n goes to infinity? I get cosine of n over n squared. Oh, is that a d and e over infinity again? It is. So I still need to use squeeze theorem. So this time cosine is between 1 and negative 1. And then I divide through by the n squared so that I get in the middle here, I get this, right? So then I take the limit as n goes to infinity of negative 1 over n squared. That's 0. And then I take the limit as n goes to infinity of 1 over n squared. That's 0. So therefore, I can say that this guy converges to 0 by squeeze theorem. So while I'm here, let's just look at another one that is not squeeze theorem that has a cosine in it. If I tried to take the limit as n goes to infinity of cosine of pi over n, think about it, put the infinity in here, because pi over infinity, that's 0. Cosine of 0, that's 1. So it converges to 1. So be careful. It's not every time you see a sine or a cosine that you have to use squeeze theorem.